Well, hey, everybody, Mr. E's back with you, and we are continuing to review for our quiz on proportional and non proportional linear relationships. So, in our previous video, I went through Module 4 and talked about proportional relationships and some of the key vocabulary terms and ideas there. Now we're moving on to Module 16, which continues the discussion of proportional relationships. And after that, we'll jump right into Module 17, which talks about linear non-proportional relationships. All right, so we talked about the constant of proportionality, k, in our last video, which is equal to y divided by x. Remember, if you have two variables, y and x, if y divided by x is a constant, that is called the constant of proportionality, and we use the letter k to represent it. The constant of proportionality. Why they didn't use c, I'm not so sure, but they call it k, the constant of proportionality. Remember, the equation is y is equal to k times x. So a proportional relationship says if you want to know how to get the second variable, you simply take the first variable and you multiply it by a constant. All right? That constant turns out to be a constant rate of change. Therefore, when you graph it, we said you get a straight line, which is kind of unnecessary to say because all lines are straight. You get a line that goes through the origin, right? We get a line that goes through the origin, and the slope of that line is equal to k, which is equal to the unit rate, which is equal to the constant of proportionality, which we said, which is equal to the constant rate of change. And just remember, all right, just a reminder, k is equal to y divided by x. Slope is equal to change in y over change in x. Those two things are different in a non-proportional relationship, but in a proportional relationship, you get the same result. So the same result for a proportional relationship, okay? So again, very soon, in just a few minutes, we're going to be talking about non-proportional linear relationships, and then slope means something different, but in a proportional relationship, they are the same, right? So if I were to look here at this line and I wanted to find the slope of this line, say if I went from that point to that point, it goes up. How much does it go up? 1, 2, 3, and over 2. So the slope of this line would be 3 over 2. Now, if I take any point on the line, like that point right there is 4, let's see here. Sorry, let me get this point and see if that's correct here. 412? You know what? I just noticed the scales are different. So actually, you know what? The slope is not 3 over 2. I got to be careful here. All right, let me do that again. I was going from this point to that point, right? If I go up, if we actually take a look at the scale, I went from 12 up to 18, so that's up 6, and then that way I went from 4 over to 6, that's 2. So the slope is actually 6 over 2, which is 3. All right, so you got to be careful not just to count the boxes when you're finding slope. I was not careful, but you know how I knew I was wrong? Because when I got to the point 412, I knew that y divided by x was 3, and I knew it was supposed to be the same as the slope, and they didn't match, so that made me realize my mistake. But I should have been more careful. When you're finding slope, you must look at the scales. And if the scales are not the same, which they are not, this one goes up by 2s, this one goes up by 1s, then you cannot just count the boxes, okay? So in this case, the constant of proportionality, 12 divided by 4 was 3. In fact, for any of these points here, if you take the y divided by x, you're going to get 3, and the slope is 3 as well. We can also see that in this table, right? If I take any of these points, right, 9 divided by 3 is the same as 12 divided by 4, which is the same as 15 divided by 5, which is the same as 18 divided by 6. All of those equal 3 over 1. So that's what k is. Now, slope is the change in y over the change in x. And you could see this goes up by 3 when this one goes up by 1. This one goes up by 3 when this one goes up by 1. This one goes up by 3 when this one goes up by 1. All right, so this is y divided by x is k, and the change in y over the change in x for all of these was 3 over 1, which is m. But our rate of change and our constant of proportionality are the same, and we get y equals 3x, right? Because the equation is y equals kx. It's also y equals mx, but again, we get the same result because for a proportional relationship, m and k will always be the same. Okay, so that's a quick review of those things right there: constant proportionality, proportional relationship, and slope. And again, slope, I just want to remind you, that is the constant rate of change. And because it is constant, that's why you get a linear relationship, okay? And then, here we go. Remember, slopes, they can go up from right to left, in which case they are positive, right? So if I have a slope, let me put arrows on both ends here, all right? If I have a slope like this, that's a positive slope, right? If I have a slope like this, like the one in the graph, that's a negative slope, all right? If I have a slope that goes straight across horizontally, that is a slope of 0, all right? And we haven't really talked about it, and I will not quiz you on it, but you'll be learning more about this next year. If it goes vertically, that slope is undefined, all right? But I do expect you only to know positive, negative, and 0. I'll leave undefined for next year, all right? Slope, change in y over change in x. We call the change in y the rise. We call the change in x the run. All right, you notice they went up and left. I do want to remind you, you could also go down and right, which is actually what I would do. It's actually 3. If I were looking at this, I would go down and right? So this one would have a slope. They have 3 over negative 4. I would have done negative 3 over positive 4. However, if you did those lesson quizzes that we went through, you know that I had questions specifically about this that shows both of those are correct. Okay? Alrighty, what about some questions here? Some practice exercises. Okay, the table represents a proportional relationship. Write the equation that describes the relationship. All right, so what are we looking for? We're looking for y equals k times x, and remember k is equal to y divided by x, and I can take any of these. There's my x, there's my y, right? So I could do 3 over 6, or I could do 4 over 8, or I can do 5 over 10, or I could do 6 over 12. All of those equal 1/2, okay? So k is equal to 1/2. So my equation would be y equals 1/2 x, all right? And if I graph those points, I know that my slope will be the same. All right, so here we go. So this is 2. So 3 would be right here, right? 3, 6. Excuse me. I don't know what that was. 3, 6 is right there, right? 3, 6, 4, 8. All right, 4, 5, 6. Why would they give us these points and then not make them fit on the graph? Am I mixing these up here? I am mixing these up here, huh? All right, it's x and then y. Forgive me. All right, 6, 3. I knew something was wrong. All right, 6, 3 is right there, okay? 8, 4 is right there. 10, 5. We're usually used to the y values being greater. That's what threw me off, all right? And 12, 6. All right, and then I can connect those with a line. Let me drop the second arrow. All right, and then I'm going to go, and remember, every proportional relationship will be linear, and it will go through the origin. All right, there we go. That's the first question. Let's take a look at that one. Find the slope and the unit rate. By the way, we talked about unit rate in the previous video, and remember, slope in a proportional relationship, slope and unit rate will be the same. Okay, slope and the unit rate in a proportional relationship will be the same. All right, so let's go ahead and find the slope. So remember, when you're finding the slope, you want points that are on the line and on the grid. On the line and on the grid, it looks like it goes up 2 and over 1, doesn't it? Up 2 and over 1, just confirming that the scale is the same. All right, so the slope is equal to 2 over 1. So the unit rate, we're going to apply the units to that. What do we have? All right, we have words and we have minutes. So it is 2, right? 2 what? 2 words per minute, right? For every minute I go over, I go up 2. All right, so 1, if we took a look here, we'd have 1, 2, right? And then we have 2, 4, and then we have 3, 6, and we have 4, 8. All right, and by the way, that's also k. If I do y divided by x, I get 2 every time. So the slope, the unit rate, and k are all the same for a proportional relationship. All right, what about this one right here? Again, we're looking for points on the line and on the grid. Now we got to be careful. I think that one right there. All right, and I've told you before, if you're not sure, try duplicating it again. So this one looks to go up 2 and over 1, 2, 3, 4, 5, right? So it looks like the slope is 2/5. Well, if it is, if I do that again, up 2 and over 1, 2, 3, 4, 5, I should be back on the line, and it sure looks like I am. All right, so I would say my slope is 2/5. So my unit rate is what? 2/5 of a foot per second. Now, what that means is it's actually 2 feet every what? It's 2 feet every 5 seconds. That's what you're going, 2 feet every 5 seconds, but that's not a unit rate, okay? Unit rate, that second unit right there must be 1. All right, I'm sorry, that second rate, the number there for that second value, that second quantity, that's the what I want to say. That second quantity has to be 1, and that number is not a 1. So instead of 2 over 5, what do we get? We get 2/5 over 1. So that second quantity has to be a 1 if it is a unit rate. 2/5 of a foot per second. Or if you wanted that as a decimal, 2 out of 5 is the same as 4/10, right? 4/10 of a foot per second. That's our slope. That is also our constant of proportionality. Take any point on the line, right? That point right there is 5, 2. If you do y divided by x, you get 2 over 5, right? And that also would be our change in y over our change in x. That also is 2 over 5. Because remember, in a proportional relationship, the constant of proportionality and the slope are the same. It also is the unit rate. Okay? All right, so I have decided I'm going to go ahead and stop here and make a third video that covers Module 17, non-proportional relationships. All right, I hope this review helped remind you of things we previously learned. Okay, until our next video. Bye.